Hi, I'm Beth from My Tutoring Bee, and today we're going to be talking about transformations. So we're going to start with talking about translations, rotations, and reflections. So translation is basically just any shape that is moved from one spot to another. There's nothing else that's changed about it. The size doesn't change. The orientation doesn't change. It just is moved from one place to another. It can be left or right, up or down, or a combination of those things. A rotation is when something is rotated. Think about like a clock or rotating a doorknob. So it is actually flipped over like this. And there are different degrees of rotation, like 90 degrees, 180 degrees, 270 degrees, which we'll talk about with our graph in just a little bit. And then a reflection, I think we are all familiar with the term reflection. When we think about mirrors, we are just seeing the opposite of that shape or that figure across a certain line that is described. So let's actually look at these on the graph. So let's start with a translation. Here we have a quadrilateral ABCD, and we want to translate this. And you might see this being asked in several different ways. You might see something just as simple as shift right 3 units. Or you might see an actual example of a coordinate pair, and it's wanting you to now change this to x plus 3y, meaning that the y values are not going to change. The y values will stay the same, but the x values, you'll add 3 to each of them. So let's actually talk about that with transformations. With a translation, your points, we see that A, B, C, and D are labeled here on our quadrilateral, but all of these lines, the line segments that are between the points are actually just an infinite amount of points in between each of those endpoints, right? So what we're doing is we're shifting all of those x values 3 units more, or all of those x values, we're adding 3 to them. So let's actually give some of each of these points coordinates. So for our A point, let's see, we have 1, 2, 3, 4, 5, 6, 7, -7, and then we go up 1, 2, 3, 4, 5. We have -7, 5 for our point here for point A. Point B is 1, 2, 3, 4, -4 is our x value, and then y is the same as point A with a positive 5. And then point C, let's see, if this was -7, this would be -9. And then it goes down 3 units, so -3 for our y value. And then our x value for point D, it looks like -2, and then -3 for the y value. So if we're using our coordinate pairs in order to satisfy what this is asking us to do, x plus 3, we could simply just add 3 to each of these x values, and then that would give us the location of our new quadrilateral. So we can simply add 3 to all of our x values, or what I'm going to try to do with this is actually just slide this entire figure over 3 units. So I'm actually looking at the A point right here, and I'm just counting 1, 2, 3 units to the right. So that is my new figure. And we usually label these with prime. So this would now be A prime, this point would now be B prime, this point would now be C prime, and this point would now be D prime. So let's actually look at the coordinates of each of these points to see if it does fit what we were talking about with just adding 3 to the x value. So our new A prime point is at 1, 2, 3, 4, -4, 1, 2, 3, 4, 5. So we're at -4, +5. And our B prime is -1 and then up 5. So -1 for our x value, +5 for our y value. Our new C point, C prime, 1, 2, 3, 4, 5, 6, is -6. And then we still are down 1, 2, 3. Sorry, -3. And then now D prime, D is over here, it has a positive x value, so its x value is 1, and then -3 for the y value. And let's actually do the math on these x values to see if our translations worked out. So -7 plus 3, that does give us -4. And the y value didn't change at all. So all we're doing is adding 3 to the x value. For b to b prime, -4 plus 3 does give us -1. And then again, our y value doesn't change. That remains at 5. Our C point, -9 plus 3 does give us -6. And again, the y value didn't change. They're both still at -3. And then our D point is -2 plus 3, which gives us +1. And then the y value, again, didn't change. So when you're working with translations, I really encourage you to identify the coordinates of each of those points on whatever figure it is that you're looking at and make those adjustments to the x or y values. Sometimes you'll be asked to make translations for both the x and the y values. So this figure might have also shifted up or down, and that would have affected the y values as well. Now we're going to look at the reflection. I skipped over rotation for now. That one is a little bit more complex, so I want to save that for the end. So we're going to take a look at reflection. So you'll be given instructions on where to reflect, which line to reflect your figure across. So for example, you might be asked to reflect across the y-axis. And so, of course, we know that the y-axis is this vertical line that goes through our graph. And so we want just it to reflect from one side over to the other side. So a lot of times what an easy way to do these types of problems is just to count the measurement between the line that you're reflecting across, so in this case the y-axis, the distance between the y-axis and each individual point. So for what I mean by that is, let's take a look at point D. This point is 2 units away from the y-axis. So that is where our new point is going to be over on the other side, 2 points away. So that's where we're going to put D prime, right? And then if we keep continuing across with C, we can count how far away C is from the y-axis. So we know we've already got 2, 3, 4, 5, 6, 7, 8, 9. So that means it's going to be 9 units away over on the other side. 3, 4, 5, 6, 7, 8, 9 right here. We always can use the coordinate pairs for each of the points as well. So D right now is at -2, -3, and C is at -9, -3. So when we reflect it across the y-axis, the x coordinate is actually going to change signs, and now we're going to have a +2, -3. The y value is not affected, only the x. And then you can see that this new C prime value is +9, -3. Let's take a look at A and B. So B is 1, 2, 3, 4 units away from the y-axis. So we go 4 units away in this direction. 1, 2, 3, 4. That would be B prime. And then A is 3 more than that. So if we're already at 4 here, then 5, 6, 7. A is 7 away from the y-axis. So we just continue here to A prime is 7 away in the other direction. And again, we can look at those coordinates. B is -4, 1, 2, 3, 4, 5, +5. And A is 4, 5, 6, -7, +5. And the x value again will just change sign. So now instead of being positive, they will be, sorry, instead of being negative, they'll be positive. So now our b prime will be positive 4, 5, and then our a prime will be positive 7, 5. And then we can just draw our lines in between those points to show that reflection. So now let's talk about rotations. Rotations have some rules associated with them when you are rotating about the origin. As we know, the origin is this point right here where the x and the y axes meet. So that is typically a lot of times what you will see is rotating about the origin. And when that happens, your figure will change to different quadrants of the coordinate plane. So this can be somewhat tricky and frustrating at first, but if we focus on the actual coordinate points, coordinate pairs of each point on our figures, it helps a lot, and these rules will help a lot too. So let's talk about these rules. And again, we're talking about rotation about the origin. So there are many different types of rotations. That's why I wanted to save this one to the end of the video. We can do 90-degree rotations, 180-degree rotations, and 270-degree rotations. And we can do each of those clockwise or counterclockwise. So we have to be very careful with which thing we're being asked for when we make these rotations on our coordinate grid. So let's talk about the 90-degree rotations. Let's start with clockwise. Whatever your original x, y value is for each point that is on your figure, it is going to translate to a y negative x. Okay, so let's talk about what that means. That means that whatever number is here in the x position of your original coordinate pair is now going to become your y value, and it's going to be negative. Or if it was already negative, it's going to become positive. The sign is going to change. That's what that negative x means. So that doesn't mean that our x value, now we say our x value second, it just means that whatever that number was now moves to that position and becomes the new y value. And then, as you may have guessed, this y value, whatever this one might be, now moves to the x position. So let's actually look at that with the line segment that I have here on the graph. So let's go ahead and mark what our points are. So this first point is 3, 4, positive 3, positive 4, and the next point marked here, the end point, is 7, 4. If we were to rotate this, so we're going in a clockwise rotation, and a 90-degree rotation means we're going just one quadrant over. So we're going in this direction. Like the same way that a clock's hands move, we're going in that direction, and we're just going one more quadrant over. So let's look at what happens based on our rules. Our x now becomes a negative x, but it's going to be in the y position. So that means, let's see, let me get this color here, the green color. So that means our 3 now is going to become negative 3, and it's going to be in the y position. And I'm just going to write the coordinates out here, and then we'll plot the points. And the 4 is going to move to the x position. So this point rotates to be right here. Let's look at the second point. 7, 4. Again, we're going to take whatever value is in that x position, move it to the y position, and make it negative. So it's going to be negative 7. And then our y value is going to move to the front to the x position, 4. So now our new coordinate is 4, negative 7, right here. And we can draw a line between these two so you can see how this point has rotated around to here and this point has rotated around to here. So let's actually show that with a 90 degree counterclockwise. 90 degrees counterclockwise. we're going to start with an xy, and that is going to move to a negative y x. So you see the two numbers still switch. The x moves to the y position and the y moves to the x position. But in this case, the y is going to become negative, or its sign will change to the opposite sign that it originally was. Right now we're working with all positive numbers as our original point. So we can see it more clearly with these rotations. So let's go ahead and track this and see what it would look like rotated counterclockwise. So we're going to start with this same line segment, 3, 4, and 7, 4. And now for the 3, 4, we're going to move it and have this 3 is going to stay positive and it's going to move to the y position. And the 4 is what's going to become negative and move to the x position. So our new point will be negative 4, 3. And you can see that that makes sense for this quadrant because we would move negative 4 and 3. That moves it into this quadrant over here. So let's do the same thing with our second point. 7, 4. Again, that x value is going to move to the y position. So we're going to have a 7 here. And the 4 is going to become negative. And that's going to be our new point. So we're at negative 4, positive 7. Right there. I almost put my coordinate pair too close to that. And then we draw our line here. So you can see that this point rotated around to here, and this point rotated around to here. And if I continued on with this, in fact, I think we'll continue on with this shape and move it all the way around so that you can see that these 2 points track to make a big circle, a big donut around the origin. So let's go ahead and talk about 180-degree rotations. 180-degree. The good thing about 180-degree rotations is it doesn't matter if it's clockwise or counterclockwise because they are always going to be on the opposite side of wherever your original figure is. So because we're starting with this line segment here, if we rotate clockwise 180 degrees, it would wind up in this quadrant. If we rotate counterclockwise 180 degrees, it would still wind up in this quadrant. So there's only one rule that we need to write with 180 degrees, and that is whatever your xy value is to begin with, they're not going to switch like they did with the 90-degree. They're going to stay in their same positions, but they are going to switch their signs. Both of them will. So if they are both positive, they're going to become both negative values. If one is positive and one is negative, then they are going to switch. Whatever they originally were, they're going to flip to the opposite sign. So let's go ahead and rotate this yellow line segment 180 degrees using the coordinates. Okay, so again, we'll start with our 3, 4. That's our coordinate for that first point. And so if we make each of those negative, then we wind up with negative 3, negative 4, which again makes sense for this quadrant because that puts us at negative 3, negative 4. It puts us in the third quadrant. And then with our second point, we have 7, 4, both positive. So now both of those are going to turn negative. So we're going to have negative 7, negative 4. So that will be right here. We draw our line between. So again, let's see if we can track this all the way around. This 3, 4 point tracked all the way around to here. And then this 7, 4 point tracked all the way around to here. Or we might say that it went counterclockwise. I know my circle is not perfect here. Tracked all the way around here. But you can see that this just makes one big rotation all the way around depending on what degrees you're asked to rotate your figure. Now you might also see 270-degree rotations. These are the same as the 90 clockwise or counterclockwise. A 270-degree clockwise rotation is going to be the same as a 90-degree counterclockwise. Because what happens with a 270-degree clockwise rotation is that it's going to rotate 3 quadrants around. So again, if you can remember that we took this, maybe I'll highlight here, we took this line segment, and if we rotated it once, twice, and then 3 times, it would wind up here in the same spot that we originally put that 90-degree counterclockwise rotation. And so, as you might assume, if we do 70 degrees counterclockwise, then that is the same as a 90-degree clockwise rotation. So meaning that they both have the same rules as each other. So if you see 270 counterclockwise, you can apply the 90-degree clockwise rules for that one. I also wanted to point out that all of these are referred to as rigid transformations, meaning that if something is rigid, if something is, it won't change its shape, it doesn't, our line segment did not get shorter or longer, our trapezoid did not get larger or smaller or shrink or distort itself in any sort of way. So it was just a rigid transformation of moving one item to another location. So that is what all of these transformations are. In my next video, we're going to talk about dilations, which will make the images become larger or smaller depending on how much they're dilated. I hope this video was helpful. Thanks so much for watching. Please subscribe and like and comment below.